Alright, so today I actually wanted to start off a new series regarding Blender modifiers. Blender modifiers are actually really useful tools that you can use for your modeling practices. And I wanted to go ahead and kind of look at all these modifiers and create a series where I'm explaining each and every one of them and the entire functionality behind them. I'm also going to teach you how you can create this really cool staircase animation that I made simply with just the array modifiers, which is the first thing that we're going to cover in today's video. If you want to skip to the staircase animation, just click on the time link below. And as always, don't forget to like and subscribe if you guys want more of these in-depth tutorials, or check out some of our devlogs. And now on to the video. Okay, so I just wanted to start off with talking about the fit types, as they all work in conjunction with the offsets here that we see on the right hand side. Fixed count is exactly what it sounds like. So you would set in a number essentially to how many objects you would want to duplicate. And all it does is it sets the factor, as at the bottom over here that you see, the exact distance between them, right? So for fixed count, if we want 8 cubes, we can just put in 8. If we only want 2, we can just put in 2. It's relatively simple and easy to understand. There's not really much to it. This can just be something useful if you're, let's say, creating a fence, or in this case, just a row of boxes. And you just know you want, let's say, I'm gonna break my computer, but let's say you want 500. And you can see we've got 500 that just span all the way down. Other ways you can use fit type is you can actually select what you currently have, so my cube, and I can add another array modifier. And then let's say I wanted this one to actually not be in the x-axis, but be in the y-axis. So we'll set the y-axis to 1, same distance, or actually no, it's not the same distance, 1.4. So we'll set it to 1.4, and then we'll make the count again 500. Now you can see we've got a row of 500 cubes that we can span all the way. So that's in a very basic summary how fixed count works. Now onto fit length. Fit length is the same concept, just a little bit different. So with fit length, what we do is we say, okay, there's a total length that I want to duplicate these boxes, right? So just imagine that we've got maybe, I don't know, let's say a 20-meter rope, and we want the boxes to be on a length of 20 meters. And however many boxes that ends up being is irrelevant, but we want it to be 20 meters. So then we just add in 20 for the length. And then the relative offset is really interesting, because with relative offset, we would now, if we increase the distance between the boxes, notice how it actually cuts off the amount of boxes that we see. And that's just because we've set a limitation to the length and we've increased the distance. So now it will essentially obey the rule of this length and only move forward, and it won't increase the box count beyond that length. Next up is fit curve, which is something I actually use quite a lot in a lot of my my modeling whenever I use arrays. I'm just realizing as I'm going through this that I'm actually terrible at explaining this, but I'm gonna try and see if I can figure it out. But so how I view this is you've got a curve essentially with a distant length, right? So you can edit this curve, which is basically just a simple path curve, which you can find right over here. And when you go into edit it and you select either points, right? Let's say I move this point. Notice how the curve moves with it. Now this will become important later, for example, the staircase, where we'll animate this curve actually, and the staircase will build itself. But just know this is a handy tool, because essentially what you can do is you can create multiple objects attached to this curve, and they can all follow the same rule of when you animate the curve to increase or decrease or get longer or shorter. Now, one thing I do want to mention here is when you animate a curve, you can't actually animate the curve itself. You need to be able to animate this point. And one way that we're going to do that, and I'm going to show you later, but I'm going to show you also right now, is when you're holding Control and H, you can create something called a hook. And essentially what this does is Blender creates a control point, or let's say an object, onto that exact vertice for this curve, I guess. So when you click it, notice how it actually creates something similar to a plane axis that you would see. So once I exit out of the object, we've got this now hook, and wherever I move the hook, essentially the curve moves as well, except we're not in edit mode anymore, we're in object mode. We're moving the object, which allows us now to animate it. We'll do another example of this in the staircase. Okay, so I'm going to try and explain relative offset here. Imagine this box is just an invisible box, right? It doesn't actually exist. I'm only showing it here as a visual representation of how Blender calculates its parameters in terms of how you use the array modifier, all right? But we've got two objects, and you can see here that the distance between them is essentially 10 units or 10 meters. I don't actually know the unit of measurement that Blender uses in this case. I think it's something that you can set in your preferences. But how relative offset works is that by default, the array modifier duplicates objects along the x-axis with a spacing of 1 unit. However, when you change the relative offset value, so either by a factor of x, y, and z, or by all three of them or two of them, you can change the distance and direction of the duplicates in relation to the original object. So for example, I have the object here and it's by a factor of 10, right? So if I increase this by another factor of 10, watch how it's outside this invisible boundary box. This invisible boundary box constantly changes. You don't see it. If I move this now by another 10 units out, see how exactly centered these two objects are. If we move this, if we added, let's say, another 10 units up here, right? Our duplicated objects up there. The boundary box itself moves up as well. Again, this is all invisible. You don't see this. See how they're exactly centered. This is how relative offset works. You can also combine it with other modifiers, such as the curve modifier, to create more complex and organic arrays of objects. We're gonna essentially combine this eventually down the line with something else for our staircase, but this just explains it to you. If we increase this object count by another 2 or 3, let's say we'll make it 5, it's a consistent distance between each of them, and this boundary box is essentially increased each time by that factor. So that, in a very basic nutshell, the only real thing you need to know about it is that you can set a fixed amount and a fixed distance for a relative offset between the centers of your object that you're duplicating. Okay, so now I want to move on into constant offset. Also, another one that you're going to use quite a lot in conjunction with relative offset. So just like the relative offset, the constant offset controls the distance and direction between each duplicated object in the array by adding a fixed offset to the previous object. So the way I like to kind of look at this again is, imagine there's an invisible box, a bounding box, and this box is essentially a 20 by 20, perfect square, all right? So what constant offset now does is you give it a distance of 10 meters over here, or 10 units. Essentially what happens is it's saying that the distance between the center of this object and the center of this object is 10 within relative to the edge of the bounding box. So your object as a whole has a consistent bounding box all around it. Another way that I can demonstrate this is if we set this unit here, y to 10, and we set the z to 10. It stays within the overall, think of it like a sphere, or not a sphere, like a shield, like this massive invisible force field or shield around your center object. If I set this to -10, it's still in the box. If I set this to -10 here, still in the box. Let's set it to -5, still in the box. If we bring this down to 0, it's still in our bounding box. And that's what consistent offset essentially works, right? If we increase this to a factor of 20, and we'll make these all 0, so it's increased to a factor of 20. Essentially what you're saying is this box here, I'm gonna scale this by 20. It's not exact, but you can see over here, the dimensions have doubled. But essentially what's happening is the same thing, right? This bounding box, which is now around your object, so it's not relative to it, it's a consistent offset, which means its invisible box technically increases the entire time as you increase your distance. We make this now 20, it's still in the box. If we make this now 20, it's still in the box. If we make them 10, but the Z is 20, it's still in the box. So that's basically in a very easy, well, I don't know if this is easy for anyone or if I'm explaining it even remotely right, but this is how I tend to look at it. There's this invisible box for the consistent offset that increases or decreases depending on the distance that you give your X, Y, or Z. Okay, we're almost done with this, I promise, but next up I want to talk about is object offset, and it's exactly what it sounds like. Essentially what happens is you have an empty object, which again you can just create by selecting an empty plane axis or arrows, doesn't really matter. And all you're doing is you're saying, you're creating an array modifier, select object offset, and you say, hey, listen, I want you to make a copy of everything in relative to the position, the world position of an object. And in this case, we used an empty, all right? I guess I can actually demonstrate this again. So we're gonna create our plane axis. I'm just gonna scale it up so you can see it. Don't forget, every time you scale something in Blender, you need to essentially just apply the scale. And now I'm just gonna take my little drop icon, select the empty object. Now if I move this, and let's say we'll want five counts, a fixed count of 5 for the amount of boxes we want. Whenever I move this, see how it creates exactly 5 objects. Again, this will come into play with our stair example. But now we've got 5 objects and they will be distant from like exactly the same distance. Each one of them will be the same distance from how this object is distant from your original. Okay, so let's say I want an object to be a certain distance, but I don't actually have any way of measuring that distance, but I know the top of this maybe wall that I want the object to sit on top of. So I can turn on my vertex snapping, set the object offset to this empty, and then just kind of snap it on there. And voila, that's all you need to do. So this will come into play again with our stair example that I'll be showing off in a minute here. Merge is pretty easy to understand. Essentially, you've got 2 objects and you want a certain gap between them to be combined because, I don't know, for one or other reason, you don't feel like playing around, and it sounds silly, but you don't feel like making this exact. This happens with me a lot of times. I couldn't be bothered to do this. So then you would just increase the merge distance here. So make sure you select merge, and then you just increase the distance. When you increase the distance, it will snap. And once it snaps, once you apply that, they're merged right in the center. Same kind of thing. All right. Caps. All right, I don't use this one a lot, but I do want to just briefly explain how it works. Essentially, what happens is, let's say you've got your array object, right? And I've got the counter to, we'll say 4, with a factor of 1.5. So they've got a relative offset 1.5 between all of them, We'll even make it that it's 1.5 in the Y just to demonstrate this a little bit easier. And I've got two other objects, and I want this one to be at the beginning of this array and this one to be at the end. And I don't feel like individually moving them there and there, right? It can get, when things get a lot more complex, this will make sense to use, but I just want to show you how it applies now. All you need to do really is just take your start cap, so it's saying at the start, the real start of your object, and I select the code. So now it makes, essentially this is still the beginning of your object, but now you've set something before it at the same distance between their centers. And now if I wanted the same for the end cap, the same distance but a different object, I can again select the end cap, and now you've got the ball over there. And again, remember, Blender creates everything from the centers of these objects. You can see by just using the plain grid, and by me making everything at perfect factor of 1.5, it's at the center of this cone to the center of your object. Just like this object is duplicated over there from the center to the center. Everything works in centers with Blender. And that is caps. And that's it for all, just basically a very academic breakdown of each object. I don't want to go too much into UVs, but I will just briefly explain it here for you. So just in very basic layman's terms, UV offset in Blender refers to the ability to shift or move the texture of an object in the 2D UV space. So if you think of it like a piece of paper that has texture printed on it, the UV coordinates of the object specify how that texture is applied to the object's surface. When you adjust the UV's offset, you are moving the texture around in the 2D UV space, which turn affects how it's applied to the object surface. If it doesn't make sense, it's okay. I guarantee you're not gonna really use this. And it's why I never really I don't really think it's worth explaining. Okay, now comes the fun part. So I'm gonna show you how you can create essentially this animation here. And what this animation is doing is actually creating, using the array modifier to create the staircase that slowly winds up. I'm not focusing on the lighting or any of the animation aspects. I only want to show you how I created this so you can do something like this yourself. Here's what tasks that I have. You're gonna create a center pillar. So go right now, create yourself a center pillar. It can be anything that you want it to be, and create yourself some stairs. Now, when you decide on your stairs, you can have it 3 like I have it here, and I only did this for variety reasons, or you could have it just 1, 2, 5, 10. It's up to you. Obviously, I would recommend not going beyond 5 because then you're not really gonna see the animation play out super well. But I'd say recommend 2 or 3, or 1 even, but 2 or 3 for variety. And then when you're done with that, come back to the video and then I'll explain what to do next. Okay, so you've created your stairs and your pillar like I asked. Now what we're gonna do is we're gonna add on the array modifier. So you're gonna go add modifier, click on array. And we want this to run into a fit curve because we want it to go up and down in relative position to the curve's length. So click on fit curve. And you can see here we don't really have a curve for it to work on. Now we need to go and create that path curve that I showed you guys earlier about. So go add, and then go to the curve section, click on path, and you'll see it's kind of there, but it's not facing the right direction. So just isolate it, and then all we're gonna do is we're just gonna rotate it on the y-axis, make it 90. Go into edit mode, make sure you select the 3 middle vertices, and you're gonna want to delete them. Come into your x-axis view, bring the bottom vertex up. It doesn't have to be right on the center of origin, but just make it pretty close to it. And then you're gonna exit that and come back to your original view. Now, something like this can get a little confusing, so let's make sure our file structure is correct. This is our curve, the NURBS path 001. We're gonna rename that to path and we're just gonna put it in our practice folder. Then we're just gonna take our stairs. We're gonna rename this to, you guessed it, stairs. We're gonna take our pillar and we're gonna rename this to pillar. Great. Make sure you're good at this naming convention or just naming your stuff in general, because it can get really confusing after a while. So now we've created our curve. We're gonna take a little dropper icon and we're gonna select our path curve because we want it to run along the path. Make sure your X factor is set to 0 because we're not looking to do relative offset on the X axis. We're wanting to do one on the on the Z axis, sorry. So on the Z axis. So set your Z axis to 1. Now, just to demonstrate this, if you go into your path curve and you take your vertex point, and let's say you just scale it up, you see what happens? So now our stairs are going up in relative position to the vertex or the length of this curve. But we have a problem. It's not rotating properly. And that can be easily fixed. And this is exactly where our object offset and constant offset comes into play. So we're gonna put on our constant offset. We don't want it to go on the X distance. We're gonna put that to 0. But we do want it in the Z distance. And for me, you can play around with these values, you know, kind of figure out how high or how low you want it. For me, I wanted it at around -0.4. Felt like that gave a little bit of a good feel because they're kind of intersecting each other then. Now, how do we get it to rotate? This is where object offset comes into play. Now, we don't have an object to rotate it by, so we need to create a new object. So you're gonna go add, make sure you go to empty, and make sure you select plane axis. You can't really see it, so we're gonna kind of just scale it up. Again, remember, every time you scale something, you need to apply the scale. Otherwise, you're gonna get weird transforms. So apply the scale. Once you've applied the scale, let's rename this guy. So we're gonna name it to center rotation. Okay. Move that into practice. Now all that's left to really do is essentially tell our modifier, hey, we want you to rotate these stairs in accordance to the object of this center rotation. So select your drop-down icon, select your center rotation. Nothing's happened. Well, that's because the rotation is actually 0, right? So now you're gonna press R for rotation, and you're gonna press Z because you only wanna rotate it along the Z axis. You want it to turn clockwise, counterclockwise. So press Z, and then you'll see it starts rotating. Isn't that nice? So I found just maybe something around, just around 50 degrees works. You can also see it up here, 50-degree rotation. You can make that whatever you want it to be, but 50 degrees works for me. All right, so we've got our rotation, great. Now what happens is if we select our path, let's go into edit, and we take that vertex point. When we move it up, you'll see your stairs actually start rotating as they go up. And if we look at it from a top-down point of view, it's in the exact boundary of the circle that we want it to be. So great, good. So now we want that same logic to apply to our center pillar. We want our center pillar to go up, just like our stairs, but it's a separate object. So how are we gonna do that? Well, we're just gonna add another array modifier. And same thing as before, fit to curve, because we want it to follow the curve. Make sure you set the X factor to 0 and the Z factor to 1, same as before. And the curve path, we need to select our path curve. So we're gonna select that, and look at that. It's already working. Now, I do wanna demonstrate this. Now, you don't need to set the constant offset, but let's say for whatever reason you do, right? And now you've got this little gap. What we're gonna do is we're gonna use the merge modifier. And let's say we want the pillar to just be slightly higher than the staircase in general. So you're gonna go select your merge, and you're just gonna increase the distance until they kind of snap into place there. And there you go. You've got your winding staircase that goes up and down. When you select your path, you can bring it up, bring it down as far or high as low as you want. But this essentially doesn't actually end things because you can't animate this vertex point. Now, if you remember before, I spoke about a hook, and this is where the hook is going to come into play. So we're going to bring this guy down. And next what you're going to do is make sure you're editing your path curve. Select the top vertice and you're going to hold in Control H, and this is going to create a hook. And like I mentioned before, a hook is basically just an empty object that's parented to the vertice. So great, you've created your hook object. We're going to go out of edit mode, back into object mode. Select your new empty, it's just this tiny little line here, and just move it up and down, and you'll see now it's the same thing that happens before, except you're editing it in the object mode and not in the edit mode, which means it can now be animated. So you're gonna bring up your little animation toolbar that I have over here. You can set your end and start frame to however much. I set mine to 400, but just for this demonstration, I'll make it 200. And the only thing you're gonna animate is this new empty. We're gonna rename it and name it to hook. Then you're gonna take this, press I so that you can get the location rotation. Select that. You move away from frame 1 all the way to frame 200. And then what we're gonna do is zoom out a little bit, move your hook along the Z-axis, move your hook along the Z-axis to as high as you wanted. Let's say I wanted my staircase to go up that high. And then all you're gonna do is press I, location rotation, and that's it. That's really all there is to it. Now when you bring your animation all the way to the beginning and you start playing it, you will see your animation slowly starts building your staircase. Pretty neat. And with that, guys, that's really all you needed. You just needed basically 5 objects. You need your center rotation empty, your hook, your path, which connects to your hook. You needed a pillar, some stairs, and that's about it. Everything else is pretty basic and easy for you to figure out afterwards. All that's left is just to texture your assets and add some lights and make it look really pretty. Erase is an amazing modifier. It can really affect how a lot of your animations will come into play, or even just make life easier when you're duplicating multiple objects in a large scene. Hope you guys found this video informative and helpful. Let me know your thoughts, comments, things you liked, things you didn't like. If you're interested in seeing more of the content, or if you want to even see the development process of our games that we're making, make sure you subscribe and hit the like button. It does help us quite a lot, actually. And look forward to future content where I'll be explaining some of the other modifiers and how they can be used in application with things like this animation that I just created for you. Have a good one, and I'll see you in the next video. Cheers.